Hi friends, welcome to Suneel Engineering Academy. I am Suneel Kumar Bandaru, plus educator in an academy. Students, from today onwards, we are going to practice topic-wise MCQs in power systems. This series is very useful for all of your competitive examinations like SSC JE, RRB JE and other state JE examinations and also AE examinations. Don't skip the video until the end, and if you like, share to your friends and also subscribe this channel. Let us start the sessions. Yes, first of all, we have to start with generation topic, power system generation topic. So with thermal power stations. Coming to the first question, guys. On which of the following cycles does a modern steam power plant work? On which of the following cycles does a modern steam power plant work? Carnot cycle, Rankine cycle, Otto cycle and diesel cycle. Here answer is Rankine cycle. So as per this Rankine cycle, if you are giving the heat input, we are getting the heat output, work input and work output. This is fully in the cycle manner. Fully in cycle manner. So that cycle is called as Rankine cycle. So let us understand that one. Here, according to this cycle, if we have the boiler, for the boiler, you are giving the input as heat input. Okay, and we are sending the water to the boiler by using the pump. Okay, for pump, we are giving work input. Work input in the sense water input. Water input. Okay, so by utilizing the heat, the water is going to be boiled and it will give the steam. It will give the steam and it will be enter into the turbine and turbine starts rotating. So that means it will give the mechanical output. Mechanical output, that is you are getting work output. Okay, and whatever the steam existed from the turbine will be enter into again the condenser, which condense that steam and convert it into water. Condense, and again it will become water and it will be entered to the pump. This is a complete cycle. So if you are sending the water, you are getting the steam. From that steam, again it will be converted into the water. Again that water is sent to the boiler. So this is a complete cycle, repeated cycle. In this repeated cycle, if you are giving water input, that means work input, you are getting the work output. Here you are giving the heat input and from the condenser, you are getting the heat output. Heat output. This cycle is nothing but Rankine cycle. This cycle is used in case of the modern power plant. Okay, coming to the next one. What is the approximate efficiency of normal thermal power station? Normal thermal power station. It is a very repeated question, guys. Very repeated question. This normal thermal power station efficiency is limited to 30 to 40%. 30 to 40%. Why? Because coming to the overall efficiency of the thermal power plant is equal to efficiency of the boiler, efficiency of the turbine, efficiency of the alternate. Okay, it is a turbine, boiler. Okay, so the boiler efficiency may be approximately 80 to 85%. So it is 85%. But turbine efficiency is limited to 40% only. Alternator can get up to 95%. Why this is less turbine efficiency? Because lot of heat is wasted at the turbine exhaust. Here from the turbine exhaust, here lot of heat energy is wasted now, and the steam is going to be converted into water. Here heat loss takes place. Heat loss takes place, that is heat output I have given. Okay, So heat loss takes place at the turbine exhaust. So we can say heat, or we can call it one as energy, heat energy. Heat loss takes place runner exhaust or turbine exhaust to condenser, to condenser. Okay, so a lot of heat energy is wasted in the turbine, so that's why turbine efficiency is very less. So if you multiply all these, you will get approximately 30 to 45%, 30 to 40%. So that means you are getting thermal efficiency, thermal power plant efficiency is approximately 30 to 40%. Okay, all of you clear? So we can get the boiler efficiency up to 85%, alternator 95, but turbine efficiency is less. Because of that one, the total efficiency of the thermal power plant is limited to 30 to 40%. Maximum efficiency of modern coal-fired steam rising thermal power plants is restricted to about 0.35, mainly because of dash. Why it is limited to 0.35, that means 35% or 30 to 40%. Just now I have given what is the reason. Heat or energy loss takes place turbine exhaust to condenser. So here they have given the option D, high energy loss from turbine exhaust to condenser. So can you the answer as option D. Very important question. All these questions are very important and very repeated. Okay. Arrange the following in the correct sequence in the flue gas passes through them after coming out of the boiler in the thermal power station. They have given ID fan, air preheater, economizer, electrostatic precipitate. So select the correct answer using the codes given below. How the flue gases are flowing from boiler to the next one. Okay, so first of all, from the boiler you are getting flue gases. Flue gases, they have the heat. Okay, and this flue gases will be flow through first of all the superheater. The superheater utilizes that heat in the flue gases, and it converts wet stream into dry stream. Wet to dry stream. Okay, that means it increases the temperature of the steam to very high point. Okay, after that, after the superheater, if this flue gas is still having some amount of the heat, that heat is utilized by economizer. Economizer utilizes that heat. It is nothing but, we can say, feed water heater. So water enter into the economizer. So those water will be heated by the heat utilized by flue gases. So it saves some fuel. To the boiler. Okay, so that's why it is economizer. So save some fuel means some fuel cost is reduced. So can say it is economizer. And still the flue gases having the heat. So those flue gases will be enter into the air preheater. Okay, so air is enter into the air preheater, and that air is heated by these flue gases. Those air will be sent to the boiler. Why the air is sent to the boiler? In olden days we are using the stick fires. Am I correct? So we have taken the one vessel. Here we have used the sticks and we are getting the fire. So whenever the fire is less, then what we are doing? We are giving the input of air. Like that. Am I correct? So whenever you are giving the air input, then you will get a lot of fire. Okay, so to increase the fire, we are going to give the air. If that wet air we have given, then we may not get the desirable fire. So we have to give some hot air, that is a more advantage. So in this way, the flue gases will be enter. After air preheater, it will be enter into chimney. It will be enter into electrostatic precipitator and chimney. Through that one, they will be flow outside. Okay, so here, first of all, economizer 3. After that, air preheater 2. 3 to only one option, so can give. After that, electrostatic precipitator. After that, ID fan. Okay, so after that, ID 3 to 4 1, so can give the answer as option D. Coming to the next one. So here we can understand all those details. Yes. So the flue gases will be enter firstly to the superheater and then economizer and then air preheater and then induced draft fan. Okay, and then induced draft fan to the chimney. Okay, so in this way it will be enter. It will be enter. Which coal has highest calorific value? Which coal has highest calorific value? What is the highest calorific value? What is the calorific value? Is nothing but for small amount of fuel, if we get more heat, large amount of heat is generated. We get large amount of heat, then we can say that is the high calorific value. High calorific value. Among all the fuels, hydrogen having high calorific value. Having high calorific value. So that's why that is considered as future fuel. Having high calorific value. So that is used in rockets. Okay, in case of coal, we have different types of the coal. First one, anthracite. After A, bituminous, lignite, and peat. Okay, so this anthracite having the carbon percentage nearly of the carbon nearly 94 to 95, 98%. So here you can get idea, higher the carbon percentage, high calorific value. Carbon is a fuel, high calorific value. Okay, so bituminous nearly 78 to 86%. Here lignite 70 to 78%. Peat less than 60%. It is the cheap type of the coal. Okay, anthracite is the best type of the coal, are having highest calorific value. Having high calorific value. Having high calorific value. So answer is option A. It is also in the alphabetic order only. So this highest calorific value or best type of the coal is in the alphabetic order. A, B, L, P. Like that you can simply remember. Okay. Coming to the next one. In thermal power plant, feed water coming to economizer is heated by dash. Just now we have discussed the feed water coming to the economizer. So here we are having the feed water. Just wait. Yes, here we are having the feed water. This will be enter into the economizer, that is heated by these flue gases. Heated by these flue gases. Okay. So that means here you can say the answer is by flue gases. So the answer is option C. Coming to the next one, the main function of the economizer of a boiler plant is dash. Just now I have given here, due to this economizer, what is happening? It is the water before enter into the boiler, the water before enter into the boiler, it is heated by this economizer by using the flue gases heat. So already water getting some heat. Okay, water is already heated in the economizer, then less amount of the fuel is enough to get the steam. So that means some amount of the fuel is saved. So it saves some amount of the fuel, some amount of the coal. Okay, so that means it will use the economy. So it decrease the fuel consumption. It will decrease the fuel consumption. So the answer is option C. Coming to the next one. Air preheater is placed between dash. Boiler and economizer, boiler and superheater, superheater and economizer, economizer and chimney, economizer and chimney. Where this air preheater is placed? Let us check. This air preheater is here. Here is the air preheater. It is placed between economizer and boiler. So between the boiler and economizer, we have the air preheater. Boiler and economizer, we have the air preheater. Boiler and economizer. So the answer is option E. Coming to the next one. The main function of the superheater plant is dash. I already said what it will do. The superheater, it utilizes the flue gases heat. Flue gases heat. From the boiler, you are getting wet steam. Okay, that will be converted into dry steam. So that means it increases the temperature of steam. The temperature of steam. Okay, so the first point is correct. So if the temperature increases, its efficiency also increases. Okay, efficiency of the thermal power plant is also increases. Increase the life of turbine. If that wet steam directly enter into the turbine, turbine blades may be corroded. Turbine blades may be corroded. So that means to here, if you convert this wet steam into dry steam, then life of the turbine also increases. They may not corrode. So all the options are correct. So we can give the answer as option D. Answer is option D. Okay. Coming to the next one. In coal-fired thermal power stations, what are the electrostatic precipitators? Electrostatic precipitators generally used before the chimney or installed in chimney to collect the dust. These are nothing but you can say dust particle, to collect the dust particles from the flue gases. Okay, so this electrostatic precipitator having the electrodes, if you are providing very high DC volts, okay, then all these flue gases having the dust particles, those are, you can say, non-metals. Non-metals means those are attracted by these electrodes. Those are attracted by the electrodes, and the flue gases may be somewhat free from the dust particle, and it is very high efficiency. Nearly 99% have the efficiency of this electrostatic precipitator. Okay, so these are nothing but dust collectors. Nothing but can say dust collectors. Coming to the next one. Electrostatic precipitator is installed at dash. Boiler, no. Economizer, no. Superheater, no. And it is installed before chimney. So the answer is option B. The efficiency of electrostatic precipitator is as high as dash. Just now I have given 99%. 99%. And coming to the next question, this type of question also very important. Calculate the overall efficiency of the steam thermal power plant if boiler efficiency 85, turbine efficiency 40%, alternator efficiency is 95%. These are connected in series like a cascading manner. So boiler is connected to turbine, it is connected to alternator. Okay, so all are in the series manner. So we have to calculate the overall efficiency by multiply all this. Boiler, sorry, turbine, alternator. So boiler efficiency 85, 0.85. Turbine efficiency 0.4. I already said na in this class, turbine efficiency is limited to low, that is approximately 40%. So then if you multiply this one, you will get less than 0.4, that is less than 0, just less than 0.4, that is 32.3 is there. So 32.3%. So the answer is option A or option 1. Okay, just we have to multiply. I already said now thermal power plant efficiency is limited to 30 to 40%. 30 to 40%. Only one option is there, so we can directly give. Pulverized coal means, so we have the coal is in the solid format, so we have to we have to get powder form from that. Why? Because we are not using anthracite type of the coal, generally bituminous type. So to get the high calorific value, or to get the calorific value within very less time, to get the high amount of the heat within less time, we have to convert that solid coal into powder form. So for that process is considered as pulverization coal. We are using the mills. So in the mills, if you are placed that coal, that will be converted into a powder form. You will get powder form of the coal. Solid coal to powder. Okay, so coal is broken into fine particles. And steam pressures usually used in thermal power plants are tests. The steam pressures usually we use 100 to 200. Between 100 to 200 means 110 to 170 kg. Okay, approximately you can go for 140 to 150, and we can get up, we can use 110 to 170 also. So the answer is option C. So the answer is option C. Okay. And the next question belongs to hydroelectric power stations. We will discuss those in the next session. Okay. And students, if you want to get this PDF, you can download from suneelengineeringacademy.com. Okay. You can download from suneelengineeringacademy.com. And this is my mail ID, chelpline@gmail.com. And Telegram link, you can search with @Suneel Engineering Academy and you can send a message to me. Okay. And students, if you open this suneelengineeringacademy.com, then you will get my website. Okay. In this, you can find out SSC, JEE and AE exams PDF. Here you can go for electrical engineering PDF. Here you will get electrical 6 subject theory, and after that you will get individual subjects. Okay, and if you want MCQs, power systems MCQs, you can click on this one, and here you will get. Okay, and here After that, you have to click on add to cart and click on the cart and checkout. Okay, and log in with your credentials. Okay, after that, go for the process, and at the end you have to click on my account and log in. If you log in, you will get option as downloads. Okay, if you click on options as downloads, then you can get your file and you can download for that. Okay, and students, you can also get my live classes in Unacademy platform. Here you have to open Unacademy app in the Play Store and select your goal as SSC, JEE and State AE examination and select the number of months. Enter the referral code Suneel Sir SSC. Okay, and if you have any credits, redeem your credits and then go for the subscription. After subscription, you not only get my classes, you will get all the plus educator classes under the Unacademy, under this SSC, JEE and AE exams category. Okay, and you can use my referral code Suneel Sir SSC to unlock the free content. So if you open this one, Unacademy SSC, JEE and AE exam subscription category, in that you can also find free live classes. If you want to unlock free live classes, you need to use the referral code Suneel Sir SSC, then you can get unlock the free classes and you can watch them. Okay, and if you have any doubt, send a message to the my Telegram channel and I will respond. Okay, thank you so much, students. And if you like my class, please share and give the comment, then I can get it as the encouragement and I will give you more sessions. Okay, thank you.